Alright, welcome to our next lesson on Pythagoras Theorem, where we will apply what we would have learned into solving these worded problems. Here is our first problem. It says a ladder is placed against a wall 12.5 meters high. The distance from the base of the wall to the base of the ladder is 7 meters. Find the length of the ladder. Now, when we're given questions like this, the first thing we should do is draw a diagram to represent the information that is given. So let's draw a diagram to represent this information. First, let's look at it says a ladder is placed against a wall. So we have our wall here, and this wall is 12.5 meters high. 12.5 meters high. Alright? And it says that from the base of the ladder, so let's draw our ladder. From the base of the ladder, alright, let's get our ladder drawn properly. From the base of the ladder to the wall is 7 meters. The base of the ladder to the wall is 7 meters. Now, this is our ladder. And we want to find the length of the ladder. Notice that what is formed here, what we see here, is a right angle triangle. With this being our right angle and our ladder forming our hypotenuse. So here we can apply Pythagoras' theorem of a squared plus b squared is equal to c squared. And c squared, or c, what we're trying to find for c, that is the ladder we're trying to find. So what is given? That the height of the wall is 12. So 12.5 squared plus the distance from the base of the ladder to the base of the wall is 7. So that is 7 squared is equal to c squared. So what you can do is pause the video there and see if you can calculate the length of the ladder. So let's clarify. So 12.5 squared will give us 156.25. 7 squared gives us 49, which is equal to c squared. So now we add, we have 205.2 equals c squared. So now to find the length of the ladder, we square root 205.25, which is equal to c. Alright, and the square root of that, the square root of our answer, we will have 14.33 meters for the length of our ladder. Now, we have another problem. It says a rope is 14 meters long and is tied to the top of a post and fastened to a peg in the ground 8 meters from the base of the post. Find the height of the post. Again, what I will encourage you to do is draw the diagram that will represent this information. So, we have a post. A post is 14 meters. No, the rope is 14 meters long. So we have a post, and attached to the post is a rope. This rope is 14 meters long. Now, it said that a peg, it's attached to a peg in the ground. That's the peg here. And the peg is 8 meters away from the base of the post. So this is 8 meters away from the base of the post. So what we are asking to find is the height of the post. So this is our rope, right? 14 meters long. That's the post that we need to find. Let's assign a value to this post. Let's say this post, let's call the post P. This side is P. So we want to find the length of the post. So we know that using Pythagoras Theorem, the square of P plus the square of 8 is equal to the square of 14. So P squared plus 8 squared is equal to 14 squared. So P squared is equal to 14 squared. We take over the a squared minus 8 squared. So we can work this out and see what we will get. What we will get is 14 squared, which will give us 196. 8 squared, which will give us 64. So 196 take 64 132. So now to find P will be equal to the square root of 132. So what is the square root of 132? That answer is 11.49 meters. So the post is approximately 11.49 meters long. So you can make or use Pythagoras Theorem, apply it in our daily lives to calculate the height or the length of an object if it forms a right angle triangle. In our next class, we will begin to look at trigonometric ratios.